Hello, my name is Marcelina Lirius and welcome to Math Monday. Today we're going to review a lesson in Algebra 1 and our students in Algebra 2 would find this very useful. You will need some supplies and I'll give you a few seconds to get your pen and your notebook. And when you're ready, let's get started. At the end of this lesson, you should be able to find and interpret key features or key characteristics of functions using graphs. Let's start with the vocabulary words. These words are the key features of functions. I want you to write this on your notebook and choose 3 words. Then describe in your own words or give your own definition. You can draw a picture or any representation that you can associate with the word. Okay, let's start with the first word, domain. And let's see how close your definitions are to these mathematical definitions. So for domain, we're referring to the set of all possible values for x, all possible values for x, or also known as input values. So if we are given a graph, to find the domain, we look at these points here, okay? What are the possible x values? If we extend this graph in both directions, what are those x values? Okay, what are those x values? Then the range is the set of all possible values for y, also known as output values. Okay, if we extend this line in both directions and look for the values for y, okay, for these points here, what are the values for y? Okay, then looking at this graph, our range here will be from negative infinity to positive infinity. This could be extended in both directions. In the second graph, okay, if we look at the domain, what are the x values? What are the x values? If we extend this in both directions, what are those x values? Okay, that would represent the domain. And for the y values, notice that, okay, this graph starts from negative numbers or negative infinity if we extend this. And it goes down, and the lowest point or the lowest value for y or for the range is at this point. So our range would start from this, from negative infinity up to this value. Okay. Then let's look at the next vocabulary words. So the X-Intercepts. So the X-Intercept is the point where the graph touches the x-axis. To find the X-Intercept, okay, I want you to draw this, sketch this on your paper or on your notebook. Draw a line from left to right, okay? Draw a line along the x-axis and stop where the x-axis would intersect the graph. This point here, which is the intersection, is called the X-Intercept, okay? It's the point where the graph touches the x-axis, and we denote this X-Intercept here, this point, by a comma 0, where a is the value or the X-Intercept here. If we look at the second graph, let's do the same thing. On your paper, sketch this graph, and let's draw a line from left to right, okay, there. Notice this is a point of intersection between the graph and the x-axis. So we call this another X-intercept. or one of the intercepts. And if we continue, there's another X-intercept for this graph. Okay, that's how you find the X-intercept for a given graph. And the interpretation is, these are the points where the graph in the x-axis, where the graph and the x-axis intersect. Okay. Ready for the y-intercept? Okay. The y-intercept is the point where the graph touches the y-axis. Okay. If we look at the first graph, which is a linear graph, to find the y-intercept, let's draw a line on the y-axis and, okay, find the point of intersection. So this point of intersection, this is when x is 0 and y is some number, and we call this as the y-intercept. Let's find the y-intercept on the second graph. And to find this, let's draw a line along the y-axis. Stop here. Notice that this graph and the y-axis intersects at this point, and we call this point as the y-intercept. Okay, the y-intercept. Okay. For the axis of symmetry, for a graph, okay, the axis of symmetry is the line that divides the graph into two equal parts. Each part is the mirror image of the other. For a linear graph, the line of symmetry is actually the y-axis. This will divide, because we can extend this in both directions, and this y-axis, which is the line x equals 0, is the y-intercept. I mean, is the axis of symmetry. Okay. Let's find the axis of symmetry for this second graph, which is the parabola. Again, it's the line that divides the graph into two parts. Okay. For a parabola, the axis of symmetry passes through the vertex. And if we draw this line, okay, this line will divide this graph into two equal parts. Notice that the right side is a mirror image of the left side. So the axis of symmetry is the line x is equal to some number a. Okay. And for some graphs, you might have a maximum or a minimum value. In this case, for our parabola, okay, the maximum value here, okay, if we extend this, this will be, we don't have a maximum value here, but we do have, okay, the smallest value for y, which we call the minimum. Okay, the minimum, notice this is the y-axis, and the lowest point on the graph, this point here, y equals some number, which we call b, is the the minimum. Okay. I'll give you a few seconds to take down notes and also create a mental picture of these words with the illustration on the graph. Okay, let's have our first example here. Find and interpret the key features of the graph. This graph is a parabola, which is a graph of a quadratic function. So the parabola faces downward. Then let's look at the domain. Okay, sketch this on your notebook. And to find the domain, I want you to stretch your arms here from left to right. Okay, how far do you think would this graph extend? So what are the possible values? So you're looking from left to right. So in this case, this parabola will actually, the domain will actually be from negative infinity to positive infinity. This could be extended in this direction here. Okay, However, the range, notice that if we look at the range, these are the y values. So we're looking at this y value here, y values, y values. But notice that we have our y value would end at this point here. So our range will be from, if we count here, this is 1, 2. So this will also be, okay, if we find the point here, this will be the point. Okay, this is 1. This will be 1, -1 here. So this is the maximum value for y, or the maximum value for our range. So our range will just be from -infinity up to 2. Or in interval notation, we could write this as y is less than or equal to 2. Follow? Domain are the set of possible values for x. Range are the possible values for y. Now let's find the x-intercepts. Sketch this again on your graph, on your notebook. Okay, to find the x-intercepts, let's draw a line along the x-axis. Okay, this is our line here, and let's stop at the point of intersection. So this point here is called an x-intercept, and we can find the coordinates of this point, which is, so this is 1, 1, 0. So the x-intercepts, you have 1, 0. And if we continue, let's draw and do this also in your notebook. I'll stop here. This is another point of intersection of the graph of the parabola and the x-axis. So this is another x-intercept. And if we find the coordinates, this is the point 3 and 0. Okay, so we have two x-intercepts here, 1, 0, and the point 3, 0. Okay, let's find the y-intercept. In your notebook, I want you to draw, okay, a line along the y-axis, okay, along the y-axis, and stop where the graph and the line would intersect. Okay, so this is the point. Okay, this is the y-intercept here. This is the point of intersection between the y-axis and the graph. And let's find the coordinates of this point. So this is 0, this is -1, -2. So this is at the point -3 for y. So therefore, our y-intercept is 0, -3. Our interpretation again for the y-intercept is, it's the point where the graph touches the y-axis. Okay, then let's find the axis of symmetry. To find the axis of symmetry, we're going to find the line that divides the graph into two equal parts. Each part, okay, each part is a mirror image of the other. Okay, this is the line which we call the axis of symmetry, which passes through the point x equals 2. So our axis of symmetry, the equation of the axis of symmetry is x equals 2. Okay, x equals 2. It passes through that point, x equals 2. Ready for the next one? Okay. Then, since this is a parabola facing upwards, downwards, I mean, we have a maximum. The maximum point is at the vertex, okay? The maximum point is at the vertex, and the maximum value for this is 1, so this is 1. So maximum is y equals 1. That's the maximum value for y, okay? And we don't have a minimum because we extend this in this direction. This could be extended to -infinity. Okay, you can take down notes. Now I'll give you one item for practice to find the key features and interpret also this feature of the graph. So that concludes our lesson for today, and I hope to see you next week.